Um, once we get through, I think, enough examples, I'll set you free on your homework, hopefully. Yesterday we went through and I just want to address this question again, and then maybe talk additional ideas, additional concepts with it. And right now what I'm going to do is actually label this side here. Let's just call this side V. Because now in a question like this, we might be told or asked, can you solve for V and solve for W? Well, as I look through this and start labeling things based off the 54 degrees, this side here is what compared to that 54 degrees? W is the opposite side. Okay? 17 would be hypotenuse, and V would be adjacent. Okay? Okay? Now, if I'm trying to find, and we're going to ask the question however you want to. Do you want to find V or do you want to find W first? It does not matter, and it usually won't. So if I want to find W like we did yesterday, I know that because I'm going to choose to find W, that is going to be the one variable in my equation. Does that make sense? And if we're going to solve these things, and right now all of our equations will be one variable, then I now have to choose every other side to be a known quantity. Okay? So, in deciding which of these to choose, which one would I choose if I have to choose a known quantity? 17. Okay? Then I think, okay, well, if I've got that information, I know I have to use the opposite side, and I have to use the hypotenuse. We said Sohcahtoa was the mnemonic phrase that allows us to decide. I use sine, cosine, or tangent. Which one am I going to use here? I'm going to use the sine one. Okay? So I'm going to say sine of my angle. When I say sine of my angle, I'm talking about the angle that defined all of the sides, their locations. And then it's equal to opposite of that angle divided by the hypotenuse. Okay? Now, every single one of these problems that we go through, once you set up this is ultimately a proportion. Okay? Because I can do that right there. Okay? You can cross multiply and solve for W. Okay? And in the past, I've taught it that way. I like to multiply by the LCM, the least common multiple of the denominator. Okay, so in this case 17, because it is identical to cross multiplying. It's the same thing. So people say, well, I'm going to multiply by, I always tell them multiply by that common denominator. Okay, that least common denominator. And they say, well, I did different. I cross multiplied. Okay, so I'll show you the link between that. So if I did that, so I multiplied both sides by 17. If I cross multiply, that's going to give me W, right? Is that going to give me 17 sine of 54? Make sense? Did you ultimately multiply this side by 17 and that side by 17? So cross multiplying and multiplying by that least common denominator here is the same idea. It's the same thing. Okay. So yesterday we talked about how none of these values here are rounded. So that is an exact value. So I'm going to put a box around that. I'm going to write that is an exact value. Okay, but if I gave you a number line and I gave you a marker and I said go up on that number line and locate 17 sine of 54, nobody's able to do that, right? Okay. So what we're going to do is we're going to grab our calculator. We'll make sure it's in the correct mode. Something also with these calculators, I'm not sure if I don't think it does it on this Desmos calculator, but this one, I think if you clear it, I'll just check. I'll go put it in degrees, type something in, don't care. Then go to delete all. See how I moved it back into radians? Does that make sense to everybody? So whenever you clear something, when you go basically hit that button and hit delete all, it's going to reset. It basically it's like hitting F5 on my keyboard here. It just refreshes the page and sets it all back to default. So just be cautious of that if you're using these calculators. If you use the handheld, you hit clear, it doesn't do that. But I need to make sure I'm in the right mode. So we do want degrees, and I'll hit 17 sine of 54. And then that value there is my rounded value. Okay, and I could be, so this is exact to that decimal place right there. Okay, I'm not certain about what this number should be. It could be a 3 or a 4, depending on what the number after it is. Okay, but 3.75 or 13.75 for most of our applications will be fine. Okay, but I want you to know that is a rounded value. Okay. So if our goal then is to find V as well, I now know W was 13.75. I now want to find V. Okay? And when I choose to find V, I know that I have to use that in my formula, because I'm going to have to use the adjacent side. Okay? Now, if that's going to be my variable, then the other segment that I choose has to be a known quantity. Does that make sense? What are my options then to choose if I'm going to have to choose a known quantity? I know I got to use V. Yeah, I could use either that one or that one, right? Here's my question. If you're interested in accuracy, what's the best one to choose? 17. Why? Okay, because it's not rounded, right? It is an exact value. Okay, so I'm going to do it both ways. I'll do it with 17, and we'll do it with 13.75, and show then that margin of error that is created by that rounding error. So if I'm going to use the adjacent side, and I'm going to use the hypotenuse, right? Which trig ratio uses adjacent and hypotenuse? Okay, so I'm going to use this one here, which is the cosine, right? So I'm going to go cosine of the 54 degrees is equal to adjacent divided by hypotenuse. What are you going to multiply both sides by? 17. So 17 cosine 54 is equal to V. Obviously, not sure where that is on the number line. So I'm going to type in 17 cosine 54 on my calculator. 9.99 is the length of that. Okay, so V 9.99, or approximately 9.99. Again, that's rounded. And this here was the exact, correct? Is everybody okay with that? All right, I'm going to do the same procedure to find V. I'll find V again, but let's use this side here. So I'm going to use the tangent one. Okay, I'm going to use the adjacent and the opposite side, and this is the one that uses that, right? So now I'm going to go tangent of 54 is equal to opposite over adjacent. Is that okay? Now this algebra here is a little bit different, still cross multiplying or multiply by that denominator. Previously, we were always multiplying by a number, right? We multiplied by 17 both times. Don't let it confuse you. The step is to always, algebraically, always multiply by the denominator to both sides. So I'm going to multiply this side by v, and they're going to cancel there, right? And we'll multiply this side by v. So now I get v times tangent of 54 is equal to 13.75. Don't let this confuse you either. Tangent of 54, through yesterday's discussion, the day before's discussion, that is a scale factor essentially, right? That is a symbol for another number. It's a symbol for a decimal between -1 and +1. Okay? So that's a coefficient right now for v. Does that make sense to everybody? So how do I get that coefficient unattached from v? How am I going to take it to the other side, though? Well, let's do this real quick. Let's say, let me actually use the calculator to see what tangent of 54 looks like. So it's that number right there. So really I've got on the left, right now my equation would really be 1.376v equals 13.75. What would you do if I gave you that equation? What would you do to solve for v? You would divide by that thing right there, correct? But that thing right there is a rounded version of that thing. So that and that are the same, right? So if you're going to divide both sides by this, when you have the equation v times tangent 54 equals 13.75, what are you going to divide both sides by here? Tangent 54, because that's the same as that thing right there, right? Does that kind of make sense to everybody? All right. So divide by tangent of 54. Something to just think about is the reason we write it this way, because this is a variable times the coefficient. Usually we write the coefficient first, right? Okay. The reason when we talk about the tangent, sine, and cosine as our coefficients, and we don't write them first, if I write tangent of 54 times v, that's not terrible because I got parentheses around the 54. But as you work into upper level courses, a lot of times the parentheses are removed, and you've seen me do this on Desmos a few times. I don't always have to put in, if I go tangent 54, I don't have to put in the parentheses there, right? The parentheses are useful notation-wise, but they're not needed. So if I put tangent 54 and then put v after it, we don't know if that v should be in the parentheses or out of the parentheses, right? Does that make sense? So if I don't put parentheses and I do that, I don't know, am I taking tangent of this, or is it what I wanted up here? So there's ambiguity there. So, and to remove that, we put the variable in front, and now there's no question of whether it should be with that 54 or not. Does that make sense? Okay. So these will cancel. Leaves me v equals 13.75 divided by tangent of 54. So let's go to our calculator. 13.75 divided by tangent 54. I get that number. Okay. Now, this was the exact value because there was no rounding when we did that way, right? This 13.75 is rounded. So if I call this, I'm going to just call this A. And I'll call this B. If I go A minus B, okay, that's tens place, hundreds place, thousands place. We had 2,000ths kind of error here. Does that make sense? Okay. Which then, if they're asking me to round to the nearest thousandths place, I could maybe run into an issue here now, right? All right. So if they ask me to round to the nearest thousandths place, we're seeing that the thousandths place, they differ by 2 here, 2,000ths. If I wanted to round to the thousandths place, the best thing to do, the best thing to minimize that number right there would be take that 13.75 number and make it bigger, or more, not bigger, but better precision, more decimal places. Does that make sense? Okay, because you see now that number went down from 2 thousandths to now 2 10,000ths, right? Okay. If I want even less error, then I'm going to go out to that 2. Even more, out to the 8. Okay. So the more I round, the greater precision for my rounded values is going to minimize rounding error for other calculations. Okay, and I think that's a huge concept. It's not geometry. That's some algebra and some number theory, but I think it's a huge topic that we need to talk about and a byproduct of our geometry. Anybody know how I can make this go to 0 completely? Right. So this 13.75 number is that number, right? It's an approximation of that number. So if I type 17 sine of 54 in, we see now that is the exact same distance that we got there. And we see now the difference between them is 0, so because there's no rounded values now in that quantity, right? Does that make sense to everybody? In our course, and if this is kind of whizzing overhead and you're confused, it's not a big deal, okay? Most of the things that we do in here, I would probably say 90 to 95% of the questions that we come across, they're going to say round to 2 decimal places, round to 3 decimal places, and you're going to be fine. You're going to figure that out. There are some questions, maybe 5% or less, that will say leave things as the exact answer, okay? When you get to Trig, though, this is commonplace in Trig to leave an answer like that, okay? The Trig isn't hard. I'm teaching you the Trig right now. What I have to teach in my trigonometry class to be able to get students to leave it this way is the algebra, okay? So make sure that you understand, and I've said this before, your high school math classes are not hard, okay? There's a lot of college math classes, graduate level math classes. So after you go 4 years of math class, and then you get into your 5th year, and after you get your degree, and you get your 5th year, and 6th year, and 7th year of math classes, those classes, the concepts really aren't hard. It's the algebra that's in them that is very, very, very difficult. And it's difficult algebra because when we were first taught the algebra in 6th grade, 7th grade, 8th grade, maybe it wasn't as important to us. We didn't see and understand that it was the thing that was going to drive all of our rest of our mathematics. Okay, so that's just something that, you know, we're in the moments of, you guys just got done scheduling, right? Okay, so when we're thinking about these upcoming classes that we're going to take, if they sound challenging or you think they're going to be challenging, they won't be, as long as you're confident and skilled in your algebra. Okay, so we got all those values. That's great. That's awesome. Okay, several different ways to do it, several different viewpoints of whether I want to be exact or I want to be accurate to some degree of precision. Let's do this. Let's find W. If that's 17, so it's the same exact problem. But instead of using this angle here, let's use the complement. So what would this angle here be? If this was 54 up here still, this one would be what? It's a complement, so 36. Okay. Now, what side would 17 be for that 36? Hypotenuse. And W would be the adjacent. Can I say what trig ratio uses adjacent hypotenuse? Yep, it's the cosine. So cosine, so Sohcahtoa, so it's cosine of 36 is equal to adjacent over hypotenuse, right? Is that okay with everybody? Just remember what we said yesterday. Yesterday, If I look at just the first equation that we had here, we had sine of 54 is equal to W over 17, right? Here we're seeing the cosine of its complement. Is that equal to the same W over 17? So W over 17 and W over 17 are equal. And sine of 54 and sine of 36 must be equal, right? But now if I cross multiply, or multiply by that denominator, I get 17. Cosine of 36 is equal to W. It's a different amount that or expression, I guess, that I type in. So I'm now looking at 17 cosine of 36, but does it yield the same result? Okay. So in the past, what I've had students working together is that student A, they'll address everything with the angle that's given, and that's fine. That's what I would suggest. It's less work. But student B will try to always use like cosine, so they'll come up with this angle here, and maybe try to develop so that they're forced to use cosine or sine all the time, which is fine. It works. But then they start arguing and say, well, you do it differently than I do, or I do it differently than you do. One of us is right, one of us is wrong. That's not the case. We got these relationships, and we're recognizing that both would be right. Does that kind of make sense? Okay. So I think it's important to be able to demonstrate and show to you guys that there are multiple approaches, there are multiple ways of doing these things. And I don't want to pigeonhole you into saying you got to do it this way. Okay. Now that may be problematic for some people when I give 2, 3, 4 different ways of doing something that are acceptable, because then they say, well, now I've got, if I've got one outfit to wear, pretty easy to choose what I got to wear, right? If I got 6 outfits to wear, now I've got a problem. Okay. Same idea here. Okay. One way to do it, then it's really easy to decide which way to do it. Okay. But if I got 3 or 4, maybe it's harder. But the reason I show 3 or 4 is because at some point, if I only show you one way, at some point that one way is going to not work for you. Does that make sense? You're not going to be provided enough information, or somehow you get a roadblock with that one way. So wouldn't it be nice to have an alternative to get by that roadblock? Okay. Take a minute, see what you guys can come up with for Y and W here on your own. What did you guys all label everything in regards to? Did you label it in regards to a 33, or did you look at this 57-degree angle here? 33, and that's my argument, is that I would always go off of what they give me, and probably 90% of the time you're going to be able to. Obviously, it'd be more work to find that angle there. Excuse me. So what would Y be in regards to that 33? Opposite. What's W? And what's 4.5? Hypotenuse. Okay. So then if I want to find Y, let's say that I want to choose Y, which other object do you have to choose if you're going to solve for Y? 4.5. So which trig ratio are we going to use then that uses opposite and hypotenuse? Sine. So I go sine of the angle that I used is equal to opposite over hypotenuse. So now what are you going to do to both sides? 4.5 sine of 33 is equal to Y. Now, just kind of keep this in the back of your mind. It might give you a good idea to make sure that you've done things correctly. I do it because it gives me a good idea of whether I'm in the right mode or not. You guys remember what sine of 30 was? It's 0.5. So sine of 33, because 33 is pretty close to 30, right? So sine of 33 is pretty close to 0.5. So in my head, if I take 4.5 and divide it by 2, I should know I get something like 2.25, right? Okay. So if I take 4.5 and divide it by this number here, or say 4.5 times sine of 33, it gives me 2.45, that's pretty close to what I thought I would get when I said 2.25, right? Does that kind of make sense? So it gives me an idea of that I'm in the ballpark. If I was in radians, that answer does not show up, right? I'm assuming, or I'm thinking I should get something around 2.25. I get 4.4, not in the ballpark. So I'm thinking, okay, check my radians. And that's the problem. Okay? So just kind of maybe use that stuff there to help you out. Now, if I'm going to find W, okay, W is the adjacent side, so you know you've got to use that. What other value do you want to use to find W? 4.5. Why 4.5 in lieu of using 2.45? Okay, no rounding there, right? So which trig ratio are you going to use then? Cosine. So cosine of 33 is equal to 4.5 on the bottom, W up here. 4.5 cosine 33 is equal to W. Is that okay with everybody? Okay. I got a question. What kind of triangle is that? Right triangle, right? So what is the number one theorem that we know should exist for right triangles? Pythagorean theorem, right? Okay. Shouldn't then 2.45 squared, because that was the leg, right? Plus 3.77 squared. Shouldn't that equal the same thing as 4.5 squared? Does that make sense? Now, why are they different here when I do that? Because I have rounding error, right? Okay, so I can make those closer by going like 0.876 and making this one 774,018. Okay, now the error is just that right now, right? Okay, 0.000005. Okay. What could I do to make it even better though? Yeah, can't I put 4.5 sine of 33 and then here put 4.5 cosine 33? And you see now that that side squared plus this side squared equals the hypotenuse squared. Does that kind of make sense? So what I like, the connection there allows people, because sometimes I get people that are uncertain about whether their answers make sense to them or not. Well, Pythagorean theorem should allow you to check to make sure your answers make sense. Okay, because you can only, right now, we can only use Sohcahtoa in right triangles. So if I were to give you a non-right triangle and ask you, find a missing side length, you can't do it yet. Okay? So that's something to keep in mind as we progress. Let's stop there for today.